All right. So the last time we met, we started a brand new unit 4, polynomials. And the first lesson covered properties of exponents. Okay. The 5 descriptions or 5 rules of exponents that we covered were multiplication of like bases, division of like bases, the power rule, the power of a product, and the power of a quotient. Okay. For lesson 2, we're actually going to start diving into polynomials a little bit more now. Okay. What lesson 2 entails is adding and subtracting polynomials. Okay. The question we're actually going to be working on this question for the next couple of videos. All right. How are basic operations, addition, subtraction, multiplication, division, how are basic operations used in simplifying polynomials? And the objective is I can add and subtract polynomials. This is what we are focusing on. We're focusing on adding and subtracting polynomials. This is what I'm looking to see what you can do. Some of the key words we're going to cover, and then I'll talk about them, is polynomial, factors, terms, and leading coefficient. Okay? First things first, operations of polynomials. Okay, so whenever you deal with polynomials, you've got two pieces. Okay, like terms, which is a monomial or one a one piece coefficient or one piece number with a variable such as 2m squared n, all right, or 2mn squared, or 2mnn negative 2mn squared. Okay, they have the same variable and the same power. Okay, the reason they are the same is they have the same exponents as well. Okay, if you notice, for example, let's take a look at these two specifically, 2mn squared and negative 2mn squared. If you notice, the m and the n squared are the same on both. So they are like, they are the same thing. Okay. These two are not, all right, because they don't have the same variables. Now, that's called a coefficient. What a coefficient entails, okay, is a number with a variable. That's what a coefficient. What a number without a variable is, or just a number by itself, are constants. All right, like 4, 6, negative 12, 1. Um, whatever number besides 0 you can think of is a constant. Okay. Now, when we are adding polynomials, okay, when we're adding polynomials, all we have to do is find all the terms that are alike and then just add those. Okay. Uh, one thing to point out that it states on the slide here is by putting in standard form, meaning from highest coefficient or highest exponent to lowest or constant, putting in order like x squared, x, it's easiest that way so that way you get an idea in order what you're looking at. If it's all over the place, it's a little bit harder to see. Okay, so let's take a look at an example. We're going to add x squared plus 2x plus 3 to 4x plus 4. Okay, so what we need to do is identify the like terms and add those. If there's no like terms and it's just a solo term by itself, guess what? He gets beaten in the final answer. We don't have to worry about any addition at all. That's it. Okay, so we're going to take a look at the example here. We're going to circle all the like terms. Okay, I'm going to circle the first like terms and I'll square the second. All right, so looking at x squared plus 2x plus 3 plus 4x squared plus 4, I see that we have two x squared and 4x squared, which means we are going to add those together. We are adding those together. All right. Next term I see is 2x. I'm going to put a square around it. Now, looking at the second polynomial, 4x squared plus 4, I notice that there's no number or term with x. It's like, so 2x gets to be in the final answer. He just gets to chill. All right, and then I'm going to put a triangle around the last term I see. So I have 3 and 4. So every shape we have, we are going to add those together. All right, we're going to add those together and we'll write out the final answer. So first things first, we're going to add the circles. X squared plus 4x squared. When you're adding like terms, you do not add the exponents at all. They carry. So we keep x squared. What we do is we add the leading coefficients, or the numbers that are attached to the variable, which in this case is 1, because anytime there's not a number in front of x squared or b third or whatever, anytime it's just the variable and the power, it's a understood 1. It's an invisible 1. All right. So there's a 1 right there. So 1x squared, or x squared plus 4x squared, all right, it's 5x squared. Now we're going to add the squares. Okay, that's the next decreasing term, is just x by itself. Like we had identified earlier, there's only one x, which is 2x. He gets the chill. All right. Last but not least, we're going to add up all of the triangles. All right. The two triangles that we have are 3 and 4. Okay, since they're both positive, we don't have to do any weird shenanigans. We'll just simply add 3 and 4, which in this case gets 7. So adding x squared plus 2x plus 3 plus 4x squared plus 4 results in 5x squared plus 2x plus 7. Okay, so that is adding polynomials. Simply what you do is you identify all the terms and then you add the terms that are alike. All right, now let's take a look at subtracting polynomials. To subtract polynomials, it's similar to addition. All right, just an extra couple of steps. First things at first, just like addition, you only subtract the terms that are alike. That's it. Okay, that's the first thing first. Just like we did with addition, we'll put it in standard form, meaning we will do in decreasing order the exponent levels from highest to lowest, or highest to just the constant itself. All right. Also, to keep from getting confused with signs, all right, because subtraction can be all weird sometimes, all right, and addition is so much better. If you don't believe me, okay, everyone's entitled to their own opinion. All right. I personally like addition better, so we're going to try to do as much addition as we possibly can. All right. We will use KFC, keep, flip, change. We are going to keep the first polynomial the same. All right. So we will flip the sign from subtraction to addition, and then we will change every sign of the second polynomial to the opposite of what it currently is. All right, so let's look at example B. We are going to subtract 3x squared plus 2x plus 5 minus 4x squared plus x plus 2. Now, it's already in standard form. We're good to go. Okay. Second thing, all right, we are going to keep the first polynomial. We are keeping 3x squared plus 2x plus 5 all the same. He is staying the same. We are going to flip subtraction to addition. All right, so we're keeping the first polynomial. We are flipping him. We are now going to change every single sign in the second polynomial. 4x squared becomes negative 4x squared. Positive x becomes negative x. And positive 2 becomes negative 2. Let me restate that real quick. 4x squared becomes negative 4x squared. Positive x becomes negative x. Positive 2 becomes negative 2. Okay? And then what we'll do now is we will align these on top of one another like this. All right? And we will simply just top to bottom add them. Okay? So 5 plus negative 2 results in 3. 2 plus negative x results in a positive x. A 3x squared plus a negative 4x squared results in a negative x squared. All right. So there's two ways of how we can do this. All right. So you can either align them top to bottom like this. All right. Line it just like a regular old addition, subtraction, or multiplication problem. Or you can break up the terms using shapes like we did with adding polynomials. All right. So what you get an idea of what goes with what. Okay. So what we're going to do now is we're going to take a look at some examples of adding and subtracting polynomials. All right. And we'll go from there.